Hello everyone. In this lecture, I will cover the differentiability of a function. First of all, I want to discuss what is the differentiability of a function. In mathematical way, you can say that I give you one limit. That limit should be exists and finite. Okay. And another way you can say that a function is differentiable at some point if in that point there exists a unique tangent. Okay, this is another way you can define, and also you can say that in that point there cannot be a corner of that function like that. If I draw, okay, this function, assume this a mod x function, no? Mod x. So that mod x function is not differentiable at x equal to 0 point because there is a corner. Okay, so if I write the mathematical definition of differentiability, first let me write differentiability of a function. Differentiability of a function. So if a function, if a function, if a function f of x is said to be differentiable at, said to be differentiable at x equal to means I can say that interior point, at an interior point, at an interior point, interior point C belongs to a interval. Okay, if this limit is exceeds the and finite. Okay, f of x minus f of c by x minus c exits and finite. Clear? Uh, Sorry, what I wrote here? Finite. Sorry, finite. So this limit must be exists and finite. And what is the meaning of this limit? You know, whenever a limit is exists, then must be left hand limit and right hand limit is equal. Okay. So this is also denoted as f dash c. Clear? So this is the mathematical way you can define the differentiability of a function. And now this differentiability have some results. Okay, I am writing all the results. Okay, first one, every polynomial function and exponential function and you can say that constant function, log function means logarithmic function, trigonometric function, trigonometric functions, and inverse trigonometric functions. Okay, inverse trigonometric functions differ all are differentiable. Okay, and second point, you can the sum difference product and quotient of two differentiable function is also differentiable. Clear? So third point, right, composition of differentiable function also differentiable. Composition composition of differentiable function is also differentiable. Clear? Now okay, these are assumed, these are remaining means these are property you have to remember. Let try to solve some questions based on it. Okay, continuity and differentiability all about the problem based. Okay, so there is no such concept like that. This is the basic concept only, or formula also limited. Okay, you have to solve questions, some tricky questions how to solve. Okay, so first question, f of x equal to, given that x box x where 0 less than equal to x less than 2. Clear? And this is box refer for like greatest integer function, and x minus 1 box x 2 less than equal to x less than equal to 3. Okay, and options are, first option, both f dash 1 and f dash 2 does not exist. Okay, and second option, f dash 1 exists. Okay, but f dash 2 does not exist. Third option, f dash 2 exists but f dash 1 does not exist. D, third option, both are exists, both exists. Okay, so try to solve. Okay, I have to apply only this formula. Okay, just try to find the left hand limit and right hand limit of that formula. Okay, our formula is, I am writing only, limit x tending to c, this is f dash c equal to, this is our formula, f of x minus f of c by x minus c, this is my formula. So the given function is, I have to check on 1 and 2 point. So first try for 1. So limit x tending to 1, f of x minus f of 1 by x minus 1. Limit x tending to 1, f of x value corresponding for the case of 1, f of x value should be x box x. Okay, minus f of 1 value, uh, so 1 into box 1, that means 1 by x minus 1. Clear? Now this is my limit. So this limit break into two side, that is left hand limit and right hand limit. I have to find left hand and right hand now. If they are both equal, then you can say that the limit is exists and finite. Okay, so for the case of left hand limit, that means limit, I can write h tending to 0 negative. In place of x you have to write 1 minus h. Just tell me yes or no. Yes, so this is 1 also, and this is x minus sorry, x, in place of x I have to write 1 minus mm, h, 1 minus h minus 1. Okay, from here limit h tending to 0 minus, so 1 minus h give you always 1 minus something, means they are left side of 1, that means give you 0 value. So this is minus 1, 0 minus 1, yes or no? Yes, na? 1 minus h means what? H is something positive number. So 1 minus something positive number become less than 1. That means I want to say, discuss. This is 0 as in, this is 1. Clear? So 1 minus h means something here maybe, because h is positive also. Na? 1 minus something positive is left side of 1. That means, so what is the greatest integer value for that particular value? This becomes left side integer. That means 0. Okay. So clear, I think. So now minus 1 and the this part minus h, 1 minus h came. That means this is like infinite, does not, left hand limit does not exist. That means in the case of the function is not differentiable at x equal to 1. Okay, okay, because left hand limit does not exist now, so why are we going for, means we cannot go for right hand limit, so does not exist at x equal to 1, the function is not differentiable. Clear? Now let's check for the case of 2. Limit x tending to 2, f of x minus f of 2 divided by x minus 2. Now limit x tending to 2, f of x value of what for the case of 2, x minus 1 box x minus 1 box x, corresponding f of 2 value should be 2 2, should be 2 here, so x minus 2, because if I put 2 here now, then that becomes 2. Okay, now limit x tending to 2, this okay, I have to find the left hand right hand limit. So left hand limit, so limit h tending to 0 negative. So in place of x, you have to write 2 minus h. Yes, 2 minus h minus 1, 2 minus h minus 2 divided by 2 minus h minus 2. So limit h tending to 0 negative, that become 1 minus h and this is 2 minus h means left side of 2, that means this become 1. Okay, so this is I think clear, minus h, and this become how, this is limit h tending to 0 negative, then minus h minus 1 by minus h. Okay, this is also does not exist. Okay, 1 by infinity, that means this is also equal to infinity, so does not exist. That means the function is not differentiable at x equal to 1 and also not differentiable at x equal to 2. That means this option is correct. Clear? Now next question. Question. mm, uh, Second question. Given function is f of x equal to x to the power p cos 1 by x when x not equal to 0 and 0 when x equal to 0. Okay, then you have to check the options are like continuous, continuous if p greater than 0, and differentiable if p greater than 1. Okay, second option, continuous if p greater than 1 and differentiable if p greater than 0. Option, third option, continuous and differentiable if p greater than 0. None of these. Third option, none. Okay. So first, let us check the continuity of that function. Uh, I told you previous in the previous video or continuous chapter. Whenever function is changing its value, you have to check there only. Okay. So here the function changing its value at x equal to 0. So you have to check continuity at that point only. So let us check. So limit x tending to 0, negative means left hand limit and right hand limit. Left hand limit, x tending to 0 negative, not x, h tending to 0 negative, corresponding functional value what, h to the power, just tell me yes or no, 0 minus h na, 0 minus h whole to the power p, I am directly writing cos 1 by 0 minus h. Clear? So this is left hand limit, so limit h tending to 0 negative minus h to the power p cos of 1 by h, because cos can take minus. So this give you whenever look here, this if p greater than 0. Okay, so 0, that means if p greater than 0, this term going to 0 whenever h tending to 0, yes or no, and this term is oscillate between 0, sorry, minus 1 and 1. Okay, so something going to 0, this is going to 0, and this is a finite oscillation. Okay, so that means the multiplication of these two things become 0 only. Yes, understood. I already means solved this type of problem in previous video, so I think clear. Now right hand limit is limit h tending to 0 positive, so 0 plus h to the power p, same, this is almost all, not almost, this is same, this is also become 0. So the function is continuous. The condition is p greater than 0. Okay, now the function is continuous if p greater than 0. This is correct. Now I have to check the differentiability of that function. So before going to check, okay, differentiability, I have to check differentiability. That means differentiability formula at 0 point is limit x tending to 0 f of x minus f of 0. I have to show that this limit is exits. Okay, so limit x tending to 0, corresponding functional value x to the power p, I think cos, okay, cos 1 by x, and f of 0 value what, f of 0 value is 0, so minus 0 by x. Okay, limit x tending to 0 x to the power p minus 1 cos 1 by x. Now tell me one thing. Okay, whenever this limit should be exits, this is, you know, now oscillating between minus 1 to 1, so this should be exits whenever this becomes 0. When this is become 0, when p minus 1 greater than 0. Okay, that means p greater than 1. Otherwise assume, if you want to say that p minus 1 is less than 0, assume your choice. That means 1 by x to the power something will be happen here, something x to the power something. So this become where this is also going to infinity, and this is oscillatory sequence. Okay, oscillatory not sequence, oscillatory means term na. This going to in oscillate between minus 1 to 1. So that does not exist. That's why p minus 1 must be greater than 0. That means p greater than 1. To exit this limit, that means to exit or differentiability, our conditions is p greater than 1. This is my condition. So I think this option A option is correct for this problem. I think clear. Question third one, f of x equal to box of x minus 2, and then options are f dash 2.5 equal to 1 by 2, and f dash 5 equal to 3. Second option, f dash 2.5 equal to 0, and f dash 5 equal to 3. And third, 2.5 equal to 0, f dash 5 does not exist. Let me write first. Both does not exist. Okay, so how to solve this problem? First of all, find the limit. Limit. I have to find in 2 point, not 2.5 and 5 point. So limit x tending to 2.5, f of x minus f of 2.5 by x minus 2.5. Clear? I have to find this limit. So now tell me one thing. What is the functional value of 2.5? 2.5, if I put here, this is my f of x equal to box x minus 2. So 2.5 minus 2 give you zero point 0.5. So zero point 0.5 box function value is 0. So minus 0 divided by x minus 2.5. Clear? So also f of x equal to what? F of x equal to x minus 2 na. Okay. Now find the right hand and left hand limit. Yeah, according to you means, so left hand limit h tending to 0 minus, in place of x you have to write means 2.5 minus h, yes, minus 2 divided by 2.5 minus h minus 2.5, limit h tending to 0 negative. So now tell me one thing, 2.5 minus 2.5, this is point 0.5, 0.5 minus h, and this is discarded minus h. Okay, what is the value of numerator? 0.5 minus h. Look here, h is something like small positive number. So 0.5 minus small positive number becomes less than 0.5. Okay, so that means the above term give you 0. That means this is equal to 0. I want to say that this is equal to 0. Clear? Okay, now right hand limit, same way, right hand limit h tending to 0 positive, then you have to write 2.5 plus h minus 2 divided by 2.5 plus h minus 2.5, limit h tending to 0 positive. So this become zero point 0.5 plus h, same way this also becomes 0, give you 0 value only. So both limits are exit. Clear? So this both limit are exits. That means from here you can write f dash, you know na, f dash 2.5 equal to right hand limit equal to left hand limit equal to 0. So f dash 2.5 is equal to 0. This is my answer. Okay, now I have to also check for the case of maybe okay, 5. So limit, I am directly writing left hand limit for the 5 case, h tending to 0 negative. So in place of x you have to write 5 minus h, yes. So 5 minus h minus 2 box function divided by Let me check once. X minus 2.5. So 5 minus h minus 2.5. I think, am I right? Okay, okay, okay. I have to like f of 5 value also na, minus f of 5 value also. So minus f of 5 value, 5 minus 3 box. I think clear. So limit h tending to 0 negative, this become 3 minus h. Okay, and this is 5 minus 3, that means box function of 2 is equal to 2, and this is 2.5 minus h. And now tell me 3 minus h give you 2, so this becomes 0. Clear? Because this value is equal to 2, 3 minus something, this is equal to 2. Now find the right hand limit. Right hand limit. So limit a is tending to 0 positive, 5 plus a is minus 2 box function minus 5 minus 3, as it is divided by 5 plus a is minus 2.5. Now limit a is tending to 0 positive, 5 plus a, this is 3 plus a, okay, this is minus 2, and this is 2.5 plus h. Okay, now tell me one thing, 3 plus h, box function of 3 plus h value give you 3. Yes, so limit a is tending to 0 positive, 1 by 3 minus 2, 1 by 2.5 plus h, and this is equal to infinite. Okay, that means 1 by 0. So this limit does not exist. That means the function is not differentiable at x equal to 5. So option should be f dash 5. This C option should be correct here, correct option. Question. Hmm.